Welcome to EDU World Space.
Here, the weight of rocket is 2,600 pound. The weight of fuel is 2,200 pound. The rate of fuel consumption is 25 pound per second, and relative velocity of ejection is 13,000 feet per second. So first of all, let's talk about the thrust here. So what I can write is P is equal to U dm upon dt. Let's write this formula in the form of weight instead of mass because we have only weight value. So U is equal to dw upon dt into 1 by g. Put all the values here. So it's a 13,000 into 25 into 1 upon 32.2. That gives me the final answer 10.093 into 10 to power 3 pound. That is my thrust. Now let's talk about the acceleration. So that will be A is equal to P by M, but again we have the weight, so I can write G times P by W minus 1 is equal to 32.2 times 10.093 into 10 to power 3 upon 2600 minus 1, which gives me the final answer A is equal to 92.798 feet per second square. Now, the acceleration as the last particle of the fuel is being consumed. So in that case, we can calculate the acceleration A is equal to by using the same formula here. This formula 32.2 into 10.093 into 10 to power 3 upon 2600 minus 2200 minus 1 is equal to 92.798 feet per second square. Now, the acceleration is calculated. Let's move further. The altitude at which all the fuel has been consumed. So in that case, I can write the formula for the velocity V is equal to U times ln m0 upon m0 minus qt minus gt is equal to minus U times ln m0 minus qt upon m0 minus gt. Also, we know the v is equal to dy upon dt. So let's compare both the above formulas and finally we can write as dy upon dt is equal to minus u times ln m0 minus qt upon m0 minus gt. Okay. Now integrating this formula with respect to time to get the altitude. So I can write 0 to h dy is equal to 0 to t minus u ln m0 minus qt upon m0 minus gt times dt. Now after integrating and simplifying, we can get the result as h is equal to u times t minus m0 upon q minus t ln m0 upon m0 minus qt minus 1 half gt square. Therefore, t is equal to wf upon dw upon dt is equal to 2200 upon 25, which is nothing but 88 seconds. Now this t value, we are going to use it in the above equation. So finally we will have the height h is equal to 13,000 times 88 minus 2,600 upon 25 minus 88 times ln 2,600 upon 400. 400 comes from because we have taken here the subtraction of 2,600 and 2,200, so the difference will be 400 here, minus 1 half 32.2 into 88 square. T already we have calculated in the above equation here. Okay, so finally we will have the h value will be 629986.75 feet. Now velocity of the rocket at that time can be calculated as v is equal to u times ln m0 upon m0 minus qt, so minus gt, that we already know. Let's put all the values here. So we will have 13,000 ln 2,600 upon 2,600 minus 2,200 minus 32.2 into 88. So finally, V is equal to 21,499.83 feet per second.